Hello, everyone. I hope you are all enjoying the conference. My name is Michał Parkoła. I'm an engineering manager at Appsilon, and it is my pleasure to introduce our keynote today, which will be about our new enterprise Shiny Apps framework that Appsilon has created and is happy to introduce to the world today. So please welcome Kamil Żyła, who is a senior software engineer at Appsilon and is one of the co-creators of Rhino, and also an author of other packages like Shiny React, Shiny Flow, and others. And then the second person involved in Rhino is Jakub Nowicki, also a senior engineer at Appsilon, who is one of the co-creators of Rhino. And finally, Marek Rogala, who is the CTO of Appsilon. So it's good to see you guys. Take it away.
Hello. Welcome, everyone. So how are you? How are you all doing? How is the first day of the conference going so far? You can write in the chat. I'm really interested to see how you feel so far. And yeah, so today we'll be introducing Rhino, the enterprise Shiny applications framework. And let's start with Shiny. As many of you at Appsilon, we are dedicated to Shiny. So why? Why do we all love Shiny? Well, it's a unique piece of technology. I think it's because it empowers thousands of people, data scientists, engineers, to create interactive, powerful applications that put their analysis in the hands of people who need that information. Shiny started as a simple tool to add interactivity to our analysis, but it has grown enormously since that. So let's explore why actually is Shiny so unique. Here are just a couple of reasons that we see. First of all, Shiny enables us to deliver value extremely quickly, right? We can implement users' ideas right away, show it to them, get feedback, improve, and repeat, and so fast, so much faster than in typical traditional technology stacks for creating web applications, for example. But also data scientists and software engineers can work together in the same code base, all working in the same language, and we can have the analysis code living together with the application code. And of course, it enables data scientists without huge programming experience in terms of software engineering to actually create applications that are super useful to people who are interested in the results. But also we can leverage the amazing community and the ecosystem of packages. And I think we in the conference so far, we've already seen how amazing the community is. I've been following the discussions, and it's really amazing to see how we all are helpful and engaged here. Right. So what is perhaps less widely recognized is that as we believe, enterprise Shiny applications, like if they are built in Shiny, applications can generally have much higher chance of achieving widespread adoption in organizations, basically much higher chance of making an impact on those organizations. And this happens in part thanks to the speed of iteration in building those applications, but also thanks to analyzing the data that is already there and making them not only visible, like with traditional BI, but also actionable. So you can really play with the data and make actions, integrate, save something, and so on. So today it's clear, Shiny is ready for prime time in enterprise. In fact, it's more. In fact, it's already used by enterprise companies in production. It's used for critical business topics. At Appsilon, we've seen customers rely on Shiny applications for drug development, clinical trials, inventory management, supply chain management, financial planning, financial monitoring, and countless other business critical tasks. Some of those solutions were covered by the press and were a source of pride for those companies. And by the way, I'm using the word enterprise here in the broadest possible sense. I think it describes really well the specific set of requirements, but I mean using Shiny applications in any demanding context in production. So also government, also NGOs, also some international organizations, and so on. So as Appsilon, we've worked with some of the biggest Shiny users in the world. Many of them, Fortune 500 companies, so one of the biggest in the world overall. And what we've experienced many times is that when a Shiny application that started somewhere really achieves the desired goals, it means a huge impact for the organization, right? And it becomes a driver of change towards more analytics-driven decision-making, and people responsible for making this happen from the organization, for coming up with the idea and then making this happen till the delivery and launching the application, often get promoted and get bigger responsibilities. So being on this conference, probably all of us, or most of us, believe Shiny is great. We know Shiny is great, but the truth is success is always at risk. There are all types of challenges waiting ahead. I've seen in the comments and the discussions, especially during the panel discussion, that many of you mentioned that it's great when you're building a POC or some experiment or an internal application that's just used by a handful of people, but getting this to production so that it's used every day, it is often really challenging. We've seen teams working months on building some applications just to end up with no impact, no users, basically no enthusiasm in the organization. We've seen apps get bigger and bigger, slower and slower, and harder to maintain. We've seen engineering teams just take away the topic, rewrite all of it to some traditional heavy technology stack. But we've also seen teams that were doing really great job in all of the areas, but losing the speed of development, which is one of the main advantages of Shiny. And basically all applications face challenges, especially if they are successful and get more and more users. But we've also seen so many huge successes. So we know those risks can be avoided. So now I'd like to ask all of you a question that we've been asking ourselves since the very first applications that we created and kept iterating on our answer. So in your opinion, what makes Shiny projects succeed? What are the reasons, what are the factors that make the difference between success and failure when it comes to building a Shiny application, especially in enterprise? Let's see. Right. What are the key ingredients to a success? I see a question about Kubernetes. That's an option for sure. Right. So let's see. Let's see. I think probably you're writing your thoughts. So please continue. Right. Ease of deployment to users. Right. Fast iterations. Mm-hmm. Right. Yeah. Working with the business teams. Exactly. Yeah. So exactly that. I see so many great answers here. So in our experience, some of the key factors are, first of all, focus on the users, like really dedication to talking to them, involving end users early and as often as possible, just to make sure that we build the right thing. And this is the key. But also great user interface and user experience. Sometimes here we can observe a huge variance in Shiny apps. Some are great, some are not so good looking. But in our experience, it really makes a difference, especially in an enterprise. Great user interface can it makes your app really stand out and encourages people to give it a try. And where this is where we have often a huge resistance to changes, and people try to avoid risks. Just this great user experience makes a huge part of getting people to just give it a try. And third, great engineering. For example, maintainability and reliability of those solutions, especially when they're relied upon, matters a lot. We don't want to start building an application, start using it, and hit a wall in 1 or 2 years. So just quality in general. And one part of a challenge is, while doing all of this, all those 3 points and more, is still to maintain the speed of development that Shiny is famous for. So, by the way, these points come from the Shiny manifesto, where our team members have captured a lot of what we believe is worth striving for in Shiny applications development. So if you're interested, you can go check it out under this URL. And I'm really interested in learning what you think. Right. So especially in this engineering area, we enjoy engineering a lot. But as we work on more and more projects, we noticed some problems that were really irritating to us as software engineers and data scientists, like repeated work, solving similar problems in different projects, or having different solutions for the same problem in different projects, but also passing knowledge between people on our team. Like, one team solves some problems, and how do we make sure that others know about this solution, especially when our team is growing. And I think these are common problems to many teams. So we really wanted to create something that addresses this. We wanted something that would make it easy and quick to start with high quality from the very beginning of the project, and maintain it till the end, or just throughout the project as long as it lives. We wanted something that would save us time, that we can instead spend on talking to the users, just understanding their problems, and building that great experience for them. So specifically, we wanted a tool that would give us a unified structure, unified architecture of applications, just provide sensible defaults and solutions for typical problems, so that we don't have to reinvent the wheel all the time. Also, that would save us time and let us avoid repetitive tasks. So it would include all the practices we care about from the very beginning. And also, we wanted a tool that would automate and codify our existing practices, so that we pass the knowledge in the form of code as much as possible, and not necessarily as documents and trainings and so on. So the story was that we started with some really simple tools. Then we even had a project in Python, which was dedicated to starting up Shiny projects. Then we actually simplified into a GitHub repo template before we eventually created a proper framework, which is an R package. So today we have the pleasure to introduce to you Rhino, the new framework for building high quality, enterprise grade Shiny applications. Rhino is an opinionated framework that captures what has worked for us over the years. So it's not the only right way to build Shiny applications, for sure. But it captures the way that worked for us. And today we are sharing that with all of you so that it can be helpful to you if you like it. So now let's switch to Kuba Nowicki, one of the co-creators of the package, who will guide you through the key features of Rhino.
Okay, so let me show you a glimpse of what Rhino can give you when you try to use it. And the very first thing that we will get when you initialize a Rhino application, it's a very rich structure, which includes the core of the Rhino Shiny application, marked here with green, where we can find an entry file app.r, where you can find your first module, main module, where you can find places to write your SAS code, to write your JavaScript code, and with a predefined nested structure for your R code with a view directory, which is intended to include all your interface of the application wrapped in Shiny modules, and logic part, which should be pure R functions, which are testable. Besides that, you will get a few more things, including the RM dependencies management, the structure for all the tests, and some extras for configuring Rhino and configuring other things like CI. So all this you get out of the box. You don't waste your time for thinking, how should I properly introduce tests to my product? How should I properly structure my Shiny application? Because this is everything given to you by Rhino. Moreover, if you in your organization uses Rhino a lot, then it is easy for you to switch between projects because everything is unified there. So again, it saves your precious time. And Rhino, besides giving you this high level of structure, also gives you a lower level. And by that, I mean Shiny modules. If you've been here an hour ago, you probably heard a lot of good things about using that in your Shiny applications. But besides that, it gives you also box modules. In fact, it forces you to use box modules. We decided to use that because box modules solves a problem that can occur especially in larger Shiny applications. If you have 20, 30 files and you use 20 different R packages, if you try using the standard way of calling that with library for packages, with source for R files, you will end up with a huge mess when someone gets to your project, or even if you get back to your project after a few months, you have no idea which function comes from which file or which package. Instead, Box forces you to write explicit dependencies in each file. So you need to provide all packages as are required, all other files that are required, and define which functions from these files are available, so you have very clear API of this file. In general, you can think about it as a micro R package, but without this whole overhead of creating a package itself. So in general, instead of this large mess, you get a very clear structure and very clear dependencies inside your application, which basically means that your code is much more readable and much easier to maintain. Rhino also gives you other things, like helps you with handling with your JavaScript code and your styles. all you have to do is write those two things in those two directories I already mentioned and compile it. Rhino provides functions for compiling both Sass and JavaScript. As a result, you will get two files, appmin CSS and appmin JS, which are both minified, which means that you already gain a little bit of speed in your application. But what is crucial here is that you will get all very powerful features of both Sass and JavaScript. So if you need to, or if you want to use, I know, arrow functions or string interpolation, Rhino will take care about compiling this into something, the JavaScript that is easily understandable by any browser. And on top of that, Rhino will also take care about handling, including all those files in your application. So there is no need for you to add call to this app, those two files to your header. It will be there just by using Rhino. Rhino also helps you when it comes to application monitoring. Now, instead of writing some weird print messages, you can use a standard in programming, which is a logger. So all you need to do is to import this log element and start writing messages on various levels. Moreover, Rhino provides you an easy way to switch those levels that are printed in particular environments. So if you need to investigate some bug in production, you can quickly change the level of produced messages to debug and be very effective in dealing with that problem. Rhino is not only a tool for enhancing your application, but it also gives you a set of tools that help you with keeping the quality of your code the best as you can. So it has a set of code style checks, both for R, for JavaScript, for Sass, together with some tools that provide you an automated formatting for those things. It also gives you a structure not only for unit tests in R, but also for the front-end tests using Cypress. And all this you get from scratch, from the day one. There is no need to configure anything. This is all working out of the box. So this makes much easier, much faster, and much more consistent to develop your application. And even if you forget to run those tools, they will be run automatically because Rhino comes with pre-configured GitHub Actions CI. So as you can see here, all those checks run automatically, and you are sure that they will run and they will inform you that something goes wrong. If you need to learn more, I encourage you to check out documentation, but I think this is the very time to check Rhino in action. So I'm passing my voice to Kamil.
Thanks, Jakub. All right, so I have about 10 minutes to give you a quick live demo of what working with Rhino looks like. This is not enough time to go in depth or cover every feature, so I will just showcase 3 important areas and give you a teaser for each of them. So we'll write some R code, and I'll show you how it is structured using Rhino philosophy. And we'll look at the other languages and Sass in particular here, and also see how testing works in Rhino. So I have RStudio open here, and I'm going to start a new project using new directory. Let's create a Shiny application using Rhino. And give it a moment to initialize. Rhino will create for us a file structure that Jakub just described to you. We are getting all the dependencies installed using renv, and this is what we end up with. So you can see all these files here, which you also saw on the first slides from Jakub. Let's check out, before we start, this app.r file. This is where you would expect an entry point to your Shiny application, and it is also the entry point to your Rhino application. It consists of just a single call to Rhino app, which is a function which does some setup for you. For example, it configures box modules, logging, and basically makes sure that everything works together smoothly. We won't be editing this file, but we can still use it to run the application. And I can use the button to do that. What you see is just a very simple hello message. This is what you get when you start a new Rhino project. So to show you how working with our code looks like in Rhino, I'd like to create a very simple module that will just ask for user's name and display a greeting message. And I want to do that according to Rhino philosophy, because as we mentioned, Rhino is not only a set of tools and a structure, but it also comes with some philosophy and ideas about how to actually build your application. And one of that ideas is to separate your code into logic that can be expressed without using Shiny, and to view which is Shiny modules and actually definition of your UI. So I will start by creating logic for my module. So in a new file, let's just define the simple hello function. It will take a name and output a greeting message using that name. I will mark this function as exported and save it under app logic directory. And I will name it messages are. So in the future, we will probably add more types of helper functions here. They all can be imported from this single file. Right now, for this very simple module, I just need this one thing. So in another file, we will now define the actual interface of the module. And for that, I will use the add-ins menu here and write a module to create some basic structure. So what I get is some structure with imports at the top and 2 exported objects. Each module needs to export UI and server. So to create this module, first of all, I will add some imports here at the top. Now, let's define the user interface. It will be very simple. There's a text input, which asks for user's name, and a text output, which will output a greeting message. And lastly, we need to implement the server portion. So I will be rendering some text based on the name provided in the input. And I will use for that the hello function that I defined in my logic portion. To do that, of course, I need to explicitly import it using box like this. So the module is ready. I will save it under app view, and let's call it hello R. So this is it for the module itself. Now we can plug it into the application. And to do that, I will go to this app main R file. This is the actual entry point to our application. This is the top level module that you see when you run Rhino application. So what I'm going to do here is to, first of all, import the module that we have just defined, and then plug its UI and server in appropriate places instead of this example code that we saw when we run the application at the beginning. So the UI goes to UI, server goes to the server, and we can now try to run the application again. And we can see that our simple module will now ask for a name and display a greeting message. So this is just to give you a taste. This is how structuring your R code according to Rhino philosophy looks like. You use box and Shiny modules to modularize your code to ensure that it is reusable and maintainable. And you divide it into logic and view to make it more testable, more robust. All right. As we talked about success factors that matter when building Shiny applications, a big one was beautiful user interface. And while Rhino does not come with styling of its own, you are free to use any package that you want to style your application. It does come with some tools that can help you to write custom styles. And by that, I mean Sass. Sass is an extension to CSS and allows us to style our application using more convenient syntax that is like better for long-term development. And just like to show you how this works in Rhino, I'm going to define a simple CSS class that can be used to center any element both vertically and horizontally on the screen. So before I use it in the code, let me also showcase you another set of tools that are available in Rhino, the linters. So Rhino comes with linters for all the 3 languages that you might be using. In this case, I want to run linter for Sass. When I run this function, first of all, I'm getting the dependencies installed. And then the file gets automatically linted. Let me run it again because I did not save the file. Now we can see that 2 errors are reported. There is invalid indentation here and the missing semicolon. I could fix it manually, but what I can also do is add a fix-through argument. This way, linter will try to fix the errors automatically. In many cases, it is able to do so. And right now, this file is already formatted correctly. No more errors were reported. So before I can use it in my app, the last thing that I need to do is to build the Sass into actual minified CSS that will be fast to load and understandable by the browser. So once I run this function, I don't need to do anything more. Rhino already includes it automatically. I can go to my main R file and use the class that I just defined in my UI. So what I'm going to do is just wrap this whole UI portion of my module in a div and apply center class to it. We can now try to run the application again. And what we can see is that the module UI is now centered. So just before we move on, a quick teaser for Sass, why you might want to use it instead of plain CSS. So let me just add some more code here. Like there are many reasons, but basically you get tools and syntax which allow you to express your code more succinctly and to reuse pieces of code, for example, by defining variables or mixins, which are kind of small pieces of code that can be used to style other portions of your application. And in this case, I will be just using this variable and mixin to add some basic background to the application. Of course, before we can see it, we will need to build Sass again. Now we can run the application, and we have some Rhino-style background already. All right, so this closes the Sass portion. The last thing, tests. Super important in enterprise, super important, I guess, in any project that is supposed to stand the test of time. So let's just go to our project directory and see this tests directory. So we have test.dat folder here that you can use to write unit tests using test.dat package that you are probably familiar with. I won't be covering that. What I want to show you is this Cypress. So here we can write end-to-end tests for our application. End-to-end tests are able to run your whole application, do some interaction with it, and verify that it works in the way that you expect it to. This basic test that you start with, just open the application and tests if it starts, but I can very easily make it do something more useful. And let me just replace the snippet. This test will now try to find the text field and type Appsilon into it, and then it will verify that the message displayed contains hello Appsilon. So to run this test, I will use Rhino test end-to-end function, and I will pass the interactive true argument to run it in interactive mode. Without it, I would just get a final report telling me whether all tests passed or not. But in interactive mode, what we actually get is this window where I can see all the files with test definitions. And by clicking on one, I can run them manually and watch the test being run in real time. I can then review what was happening step by step. So we started by opening the page, typing Appsilon in, and finally asserting that the message displayed is correct. This is super useful when you are writing tests or just debugging them. And you get this out of the box when you start a project with Rhino. So this is it for this very short demo. If you'd like to learn more, please come to a webinar, which will be happening in 2 weeks on Friday. The link to the webinar will be available at the end of the slides. And now I'm passing the stage back to Marek for wrap-up.
Thanks, Kamil and Kuba. That was great. Right, so many of the features that you saw, they're not something completely new, right? So many of them are based on existing packages like Box or existing tools like Cypress, Node.js, which compiles the Sass and JavaScript and so on. So one of the biggest advantages of Rhino is just that you get all of this integrated together in some some consistent way of building applications. Another advantage is the philosophy that comes behind it, the focus on modularization and building this really in a super solid way. So it's nothing magical, but it really saves at least us a lot of time. So you may want to try Rhino, especially if you'd like to have a scalable, reliable architecture, and you would like to follow a suggested approach to that with blocks, shiny modules, view and logic separation, and so on. Also, you may want to try Rhino if you want just to start an app with a set of pre-configured development tools, all the linters, CI, and so on and so on. And you may want to try Rhino, especially if you prefer to follow an opinionated framework built based on years of experience and only change some parts as needed, rather than build your own approach to all of the issues from scratch. So in short, Rhino makes your life as a developer of Shiny applications easier. It gives you more time to focus on the problem at hand and on the users. It helps you build your applications to the high standards you want to follow, and it lets you learn and discover new approaches and practices. So, as Kamil mentioned, we will be holding a webinar dedicated to Rhino. It's about 2 weeks from now. So if you want to see more, like how to start with Rhino, discuss with us why certain things are done the way they're done in Rhino, you are all invited. So to register, go to this link. It will be also posted in the chat so that you can click it there. If you take one thing from this talk, we'd just like to encourage you to try, to check it out. Also, if you're interested, we welcome issues, feature requests, and of course, contributions. And also on GitHub, you can go to GitHub discussions to ask questions and get answers, both from package creators and from the community. So this is the best place to get help and discuss. Rhino is the first time we are sharing how we approach building Shiny applications down to that level of technical detail. And we hope that by sharing this, it helps not only us, which it already does, but also it will help you build Shiny applications that are maintainable, reliable, modular, beautiful, and built in close collaboration with end users. And thanks to that, they achieve success. So now we have a bit of time to answer some questions. So what would you like to know? What are your questions? Please write down in the chat.
So yeah, we are gathering questions from the chat throughout the whole talk. So yeah, please everyone add your questions if you have any, and I will act as the audience avatar and with the help of our team select the best questions. So the first question is a warm-up question. Can you develop Rhino apps with other IDEs other than RStudio, for example, VS Code?
So maybe I can answer that. You definitely can. To be honest, I most often use VS Code in my work because I do a lot of development in other languages as well. And I just find it convenient to have one IDE for everything. We wanted to show RStudio here because we have a few features like this new project wizard and the add-in we thought it would be nice to present them here. But you are free to use VS Code, for example, or basically anything you'd like to.
Cool. Okay, I hope that answers the question. And next warm-up question is, what is the relationship of Rhino with DevTools and use this? Is it a replacement for those packages?
I think you can definitely it does a different thing, right? It's the main difference is that use this adds some snippets of code dedicated to specific things, while Rhino aims at building something that is integrated together. And Rhino gives you some things that that you could also get from use this, for example, CI configuration. So it replaces some of the things, but I can imagine that you still use this functions while developing your Rhino application. But yeah, Kamil, Kuba, anything to add? DevTools, on the other hand, is mostly dedicated to building packages, and Rhino applications are not packages. But you can probably end up using some DevTools call to install a package or something. But definitely, it mostly operates on a different level.
Okay. I hope that answers the question again. And now the obligatory question. So Golem exists. Why do we need Rhino?
Right. So maybe I'll start, and then also Kamil and Kuba will share their perspectives. So we think that Golem is great. So definitely we don't want to say that there is one right way to build Shiny applications. But on the other hand, we believe the best situation is when you have a choice. And you can choose depending on your context, on your situation, and on your needs. And the motivation for building Rhino is that Golem definitely works great for some projects and some people, but it didn't give us what we wanted. So it has many features that we didn't actually need, and doesn't have those features that we needed. So for example, Rhino has much more focus on giving you a consistent philosophy of building a Shiny application, much more focus on this modular and encapsulated architecture. And again, the fact that the Rhino applications are not packages, which in our experience is really helpful, especially in large applications, because it allows you to have a nested structure of directories and just split your code into logical parts, and it makes your applications more maintainable in the long run, especially if they are big. All right, Kamil, Kuba.
Yeah, I can add a little to that. I'd say that we definitely looked at Golem and considered using it in our own applications. I think one of the first stoppers was something Marek mentioned, that Golem applications are packages, and it has some benefits, but it also comes with some drawbacks, or rather limitations. For example, flat file structure. And this one, maybe it was almost a deal breaker, I could say, but once we thought that in general, maybe we don't need to build an R package, we had a lot of freedom to do whatever we want with the structure of our application. And we just wanted to have a fresh start when designing the structure of the application. So I think this was one major reason. And also, I'd say, from my perspective, the philosophy is a bit different. Rhino does not come with a set of functions, for example, for creating modules, adding data. The way you work with Rhino is a little bit different. We want to minimize the boilerplate that you have and make sure that it is easy to add your code just by putting it in the right place, instead of using functions which do scaffolding for you and such. We are still considering how this philosophy will work out exactly, but I'd say these are some additional reasons why we wanted to have something of our own.
Cool. So anything else to add, or? Okay. So maybe this was a good answer. So the next question is from a slightly different angle. So can Rhino help make Shiny apps more mobile friendly? And by mobile, I guess we can interpret it in various ways, but looking at putting them in the App Store or Google Play Store. Or is that something we are thinking about at all?
So maybe I think Rhino does not address this directly. You can definitely use SAS, for example, to help you to prepare your page to be displayed on various devices. But it's not like a matter of Rhino itself, but the fact that it comes with SAS nicely working for you. And regarding this like completely different angle of like putting apps into like actual applications that can be installed on mobile, I think we did not touch this. This Rhino application is still a Shiny application. Fundamentally, it does not differ that much.
Okay, thanks. I don't know how much more time we have. It's already 6 p.m., so we are out of time. So thank you everyone for asking your questions, and thanks for the team for answering them and giving everyone the introduction to Rhino, which is a historic event. And if your question didn't get answered, I hope we can answer it on chat, and if not, you can contact us in the various other ways that were indicated and join the webinar in May.
Like GitHub discussions for sure. I see lots of great questions here, so we'll be happy to discuss with you and also learn from you what you think.
Okay, and with that, we are done. So thanks everyone, and see you in the next session.
Thanks a lot.